Hello, humans. In this video, I'm going to explain how everything is made in an intuitive way from the perception of physics. Again, this is not an influential video, but it is an informatory video. It is just the information that I'm passing, which I have studied and learned over the period of time. In the world of physics, there is a common term which is used often, and that term is matter. What is matter? Matter is anything that you can see or experience. It could be anything. Maybe your book, your pen, your computer, your box, or a human, or a bird, or any animal or plant. Anything you can think of is a matter. These are the things that you can see, but there are certain things that you cannot see, but you can experience them. Say air that you can experience, a smell that you can experience. These are all matters. If you ever wonder how everything is made, how all these matter are made, what is happening behind the scenes, this video has answer to it, at least from the point of physics and what is believed to be true. What all you need is a little imagination and a juice of creativity and a curiousness. That's all. Let's begin. To give you an intuition, let us take a drop of water and keep looking at that drop of water. No matter how long you look at it, nothing happens and you won't see anything that changes easily. Maybe after a certain time, the water may disappear, it may evaporate, but you may question, what happened there? The thing which was there before is not there now. So let's go back to the drop of water and keep looking at it. You didn't see anything. So one thing what you can think of is, let's zoom in a little. You can take a magnifier glass and zoom into a water and see if there is anything. No, you cannot see anything yet. So your eyes, the human eyes, cannot magnify further. So we may need an instrument called microscope to magnify it even further. Let's take a scientific microscope and zoom it 2000 times. Interesting. There are few things here and there, kind of swimming in the drop of water. What are they? A drop of water magnified at 2000 times. There's nothing different there. It is still smooth, still flowing. But here and there, you can observe something called paramecia or something called cilia. So these are the microorganisms. Ever heard of those? Might be or may not be. Someone who is in the field of biology might have heard of cilia. From where the biology branches out from the physics. You can stop there. You may get curious what are these cilia or paramecia and take those microorganisms and zoom into them and study. Say you're not satisfied enough. You want to see even more further and want to understand what is there even after paramecia or cilia. Let's magnify another 2000 times for the same drop of water. If you look closely, we can see something which is no longer as smooth as water, but we can see kind of a teams, certain groups. If you want to see further what these group-like structure are, you don't have any option than magnifying it further. If you zoom in another 500 to 1000 times to the group-like structure, you can see a certain dots. What these dots are? You can see two types of dots there, a big dot and small dot. The formulation here is the two small dots are revolving around the big dot. They are bouncing, they are jiggling. It's like perpetual. They are just bouncing, jiggling, revolving around the big dots. So this is where chemistry or organic chemistry comes into picture, and this is where it branches out from the physics. Two small dots are atoms of hydrogen and a big dot is an atom of oxygen. So H2O, 2 hydrogen, 1 oxygen. This is the molecule of water. See, you have to magnify a drop of water these many times to see these molecules. Human eyes cannot see directly when you see at water, but internally this is the composition of each molecule of water. These atoms or molecules, they have a weird property. They try to attract each other when they are nearer, but they repel each other when you try to squeeze them together. Because of the attractive nature of the molecules, water gets its volume. And the jiggling, bouncing, revolving nature of the atoms is what is represented as heat. If we increase the temperature to the water, the bouncing and jiggling motion increases. Because the motion of the jiggling increases, the attractiveness between the water molecules reduces and they fall apart, vaporizes into gaseous form. So that's where the liquid water become a gas. Now that we know, by increasing the temperature, we increase the jiggling motion and eventually the liquid became gas. Take the same analogy and apply in a reverse way. If we reduce the temperature, the jiggling motion between the atoms reduces and the liquid becomes solid, that is ice form. Now that we understood, with increase or decreasing the temperature, we can convert a solid to liquid, a liquid to gas. The same analogy goes with other matters. Take for example iron. If you increase the temperature of a solid iron, there comes a certain boiling point where the solid iron become a liquid. Now let's discuss applications of it. I'll just stick to one application. In the industries, the steam is manufactured by converting liquid to gas. Later, the steam can be used to turn a big turbines to generate electricity or anything like that. So this is one of the application. So if you followed this video till now, you would have observed how the biology branched out from the physics, how the organic chemistry branched out from the physics, how the industries started manufacturing steam. But physics doesn't stop there. Physics goes beyond the molecules and the attractive nature of the atoms. Physics tries to invent what is within the atoms. I'll explain what's in there from the perception of physics in the next video. Thank you.